Okay, so we're going to make y equal to 0. Okay, so 0 equals, and we've got our negative on the outside, and then we've got 2x minus 1 inside brackets. And then here we've got x plus 5. Okay, am I going to multiply the brackets out? Good, I'm so glad you're all saying no. Okay, I'm not going to multiply the brackets out because then I'd be going round in circles. Okay, what I want is factors, okay, because I want to find the x-intercept. So I'm not going to multiply the brackets out. And I also don't need to worry about this negative over here because I can divide by -1 on both sides and it's not going to make any difference. Okay, so the negative is there to show me that my graph is sad face down. Okay, whereas the matrix may be accustomed to hearing by now concave down. Okay, it's a sad face parabola. That's why the value of A is negative. All right, so that means that one x-intercept will be at 1/2. The other x-intercept is going to be at -5. So looking at the diagram, B must be the half, and A has to be the -5. All right, so then I would simply write down here that AB is going to be a half minus -5, which leaves me with 5.5 units in length. Okay, so this question's out of 3 marks. You'd get a mark for making it equal to 0, a mark on both, and then a mark on the answer. Okay, so let's go on and talk about question 5.2. And there are 2 ways that we can answer this question, right? So grade 11s, there's going to be a method here that I'm just going to discuss with the matrix. You can listen to it, but it's something that you will do next year in calculus. Okay, the easiest way, it's only out of 2 marks, so the easiest way for us to find the coordinates at the turning point is to use that formula x equals -b/2a. Matrix, do you remember that? It's probably more familiar to the grade 11s than it is to you right now. Okay, so you can only use x equals -b/2a to find the coordinates at the turning point of a parabola. It's not used for anything else, okay, or any other function. Okay, only for a parabola. Okay, so we can do this if we want to. The only thing is that our equation is not multiplied out. So let's just multiply that out so that we can see exactly what B and A are. All right, so we know that f of x is equal to negative into 2x minus 1 times x plus 5. So if we multiply our brackets out, I'm going to leave the negative on the outside, we'd end up with 2x squared plus 10x, that would be plus 9x in the middle, and then that would be minus 5, and then taking the bracket away, we'd have minus 2x squared minus 9x plus 5, like so. Okay, now subbing into x equals -b/2a, I can see that B has a value of what in this case? Grade 11s and grade 12s. What's the value of B? That's it. Well done. It's -9. So I've got -9. Good. Over 2 times. What's the value of A, everyone? The value of A in this case is? Good. Well done. Okay, it's -2. All right, so just simplifying that, we'd end up with -9/4. Okay, negative times a negative divided by a negative will leave us with a negative. And it makes sense because the turning point is in the second quadrant. So we're expecting a negative x value at that turning point. All right, it makes sense to us. So if we were in grade 11 or in matric, we could do it this way. Matrics, the other way that you could do this if you wanted is you could use calculus. All right, so just very quickly, I just want to show you that. So this is the matric method. So grade 11s don't stress about this, but I just want to show them or remind them again. It's only out of 2 marks. So in this case, it would be a mark for subbing in here and a mark for your answer. Matrics, what you could do is you could find the derivative. So you would end up with negative 4x minus 9. At the turning point, the gradient is 0. And then you can take that minus 4x over to the other side. It would become positive 4x equals negative 9. And then when you divide by 4 on both sides, you'd get the same answer. Okay, so this is for the matrics because I've used calculus. Okay. 5.1 is incorrect. It is supposed to be 11 over 5. Let's see, Bokhang. I don't think there are any mistakes here. 11 over 2. Okay, so what's the difference between writing 5.5 units and 11 over 2? Is there a difference? It's the same thing, I'm afraid, Bokhang. Okay, just check on your calculator and you'll see. All right, it's not wrong. No difference. There we go. Ayanda, which question are you talking about? Thanks, Naliswa, quite right. Okay, so we're almost finished with this. We still need to show that the y coordinate would be 121 over 8. Okay, so I'll come back to you now. All right, so doing the y coordinate next. All right, oh wow, this whole question is actually only out of 2. So actually we wouldn't get a mark there because we've got that answer already. And now we would have to go and sub in. Okay, so either method to get the x, and then to get y, we would have to sub in f of minus 9 over 4. Okay, and that would go into negative 2. And then it was minus 9. And then I think it was plus 5 at the end, if memory serves me correctly. Minus 2x squared minus 9x plus 5, absolutely. And then we'd end up with our 121 over 8. So I suppose the other mark would be there, subbing in. Quite a lot of work, isn't it, matrics, for just 2 and grade 11s, for just 2 marks. Okay, so I know somebody said in the beginning, finding the coordinates at the turning point was something that they struggled with. Is this a little bit easier now that we've revised it? Yes, Hlumelo, okay. All right, so Hlumelo, you're in matric, aren't you? No, grade 11. Okay, so Hlumelo, sorry, I wasn't sure whether you were somebody in my class or no, you're in you're in the other class. So Hlumelo, you would have to do what we did here in green. Okay, where you'd use x equals negative b over 2a. Okay, Rosaria, you're welcome to unmute and speak. You're welcome to unmute and speak, Rosaria. Otherwise, you can always direct your question to Neliswa or to me. It's up to you, Rosaria. Oh, you unmute yourself, Rosaria. But let's see if I can help you out here. Hold on, let me just see if I can find you. Okay, so I'm asking you to unmute. There we go. You can talk.
Good day, ma'am.
Hi, Rosaria.
With the method of the turning point in my school, they taught us in a different way, which is quite difficult. And I'm still kind of struggling to understand that method specifically. So I was hoping maybe you could explain it to me so that maybe I can decide if it's a lot easier than the one that I was taught, which is a bit difficult and complicated.
Okay, so if you want to find the coordinates at the turning point of a parabola, there is one other way that you can do it in addition to what I have done here. Okay, Rosaria, are you in grade 10 or I'm in grade 11 or grade 12? You're grade 11. Grade 12. Okay. So, Rosaria, your options are to do what I've done here in green using x equals negative b over 2a. That's one option. The second option, if you're in matric, is to use calculus. So what I did here in pink, finding the derivative, making it equal to 0 because the gradient at the turning point is 0, and then solving for x. The other method is to use midpoint formula, which I can show you now as well. And then the only other way that you could do this to find the coordinates at the turning point is to complete the square. So it's only those four methods. There is no other way of finding the coordinates at the turning point. So what they've showed you at your school, I don't know, but I would have thought they would have showed you all four at some point and then encouraged you to use either x equals minus b over 2a calculus or midpoint formula. Okay, we try and stay away from completing the square as much as possible. Okay, so maybe what I need to do here is just make a little note for this, make a note for all of you on the side here. Okay, so this is how you find, and this is specifically the turning point of a parabola. Okay, so to find, and then I'll show you what to do with midpoint formula. Okay, so finding or determining is probably a better word. We don't use the word find anymore. Okay, so when you want to determine the coordinates at the turning point of a parabola. Okay, there are only four ways to do it. Okay, either you use x equals negative b over 2a, or number two, you use midpoint formula and your x-intercepts, if you have them, which we do in this case. Or you complete the square. Okay, and I'm going to put a sad face over there because completing the square is difficult, and we only ever complete the square if they tell us to. It's not a method that any teacher would ever recommend you use. And then if you are in grade 12, okay, you can use calculus. So use the derivative. Okay, grade 11s, you won't know what that means. Okay, so Rosaria, those are the only ways in which you can find the coordinates at the turning point of a parabola. So let me just do this for you the midpoint way, and then I'll show you what I mean. So because all parabolas are symmetrical about their turning point, what we can say is if we were to draw a line straight down here, this point over here is exactly halfway in between. So from A to this point is going to be the same distance as from that point to O. All right, so in other words, we can use midpoint formula. So we know what our x-intercepts are. It's a half and minus 5. So I could do this as well. I could say x equals a half plus negative 5 over 2. All right, do that on your calculators, matrix, and grade 11s, and you're going to see you're going to get exactly the same answer. I'm going to do it as well. Do you see you get negative 9 over 4? Okay, so that's the other way. Okay, so this is midpoint formula. This is x equals negative b over 2a. or we've got calculus down here in pink using the derivative. Okay, so you've got lots of options only. Completing the square only. Okay. Rosaria, you definitely don't want to do completing the square. Okay, these other three methods are much quicker and much, much easier. All right, so I really wouldn't bother with completing the square. Okay, so use either number 1 or number 2 or number 4. Okay, we are going to do another question on the parabola. So let's get on with this one, and then we can have a look at how we could maybe do it all those ways again. Okay, Rosario, you can always come back and come and watch this video again, just for a little bit of extra information. Okay, all right, so now they want us to determine the values of m and k. So remember, m and k were the variables used for m is for the gradient of g, and k represents the y-intercept. So over here, the information, it tells us that the graph of f cuts the x-axis at A and B and the y-axis at C. And then it also tells us that the graphs intersect at A and C. So in other words, A is an x-intercept for both of them, and C is a y-intercept for both of them. So in other words, we know what the value of K is already. What is the value of K? K is equal to what? Can anyone tell me? I can always go up a little bit if you want. What's the value of K? Okay, Bokang, you're close, but remember C is a point. Not yet, Jude. Oh, silly me. Sorry, guys. I went straight to 5.4. Sorry, we haven't done 5.3. Okay, sorry. No wonder you were confused. Okay, let's do 5.3 quickly and then we'll come to that. All right. Calculate the length of OC. Okay, so again, it is a vertical line. They don't want us to do distance formula or anything like that. Okay, so at C, we know that at C, y is equal to 5. Okay, so OC would be equal to 5 units. Okay, quick and easy. We can literally just write down the answer of that because it was given to us. All right, so the value of K, back to 5.4 now. Back to determining the values of M and K. We know what K is equal to. K is equal to 5. That's it, Gugu. Okay, and we know that from here, because when we multiplied those two together, but from here, this is it in standard form. Okay, this is our standard form here in yellow of f of x. Okay, so straight away we know that K is equal to 5. So we've got y equals mx plus 5. All right, we know what the coordinates are at A. We know what the coordinates are at C. We could use gradient formula. But what we could do if we wanted, that would be even quicker, would be to sub the coordinates of A in and just solve for M. Okay, so what I'm going to do is I'm going to sub in the coordinates at A. At A, I know my coordinates are -5 and 0. So I'm going to put my y over there. I'm going to put my -5 over here. And that's going to give me 0 equals -5m plus 5. I can take my -5m over to the other side. That gives me 5m equals 5. So m would be equal to 1. So therefore, the equation of this line, it would be the line y equals x plus 5. Or if you want to solve for m differently, okay, you can use your coordinates at A. You know that it's -5 and 0. You know your coordinates at C are 0 and 5. You can sub into gradient formula. So change in y over change in x. Okay, and you'd get -1 as well. Okay, so either of those two ways to work out the gradient. Sure, Hlumelo. Okay, so Hlumelo, do you remember when I multiplied these brackets out? I did that in question 5.2, and I got f of x in standard form. Okay, so if you recall, I multiplied the brackets out. I got 2x minus 1 times x plus 5. I'd leave the negative on the outside. That gives me 2x squared plus 9x minus 5. And then I multiplied through by the -1. I got minus 2x squared minus 9x plus 5. So this is f of x in standard form. So this value over here, always, 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 is your y-intercept, isn't it? Okay, the value of c. So ax squared plus bx plus c is standard form like it is now. And that value over there at the end 5 is your c value. That is your y-intercept. Yes. Oh, sorry. Oh, silly me. Quite right. Sorry, Mesh. This is 1. Sorry, it's -5 over -5. Sorry, Mesh, you're quite right. It's 1. Yes, Cassandra. Okay, so if you go back and you look here, again, it's a bit difficult for you guys because you don't have it. Well, mind you, you do actually have the question. If you have a look at the question paper, I hope you got the question paper with you. It's just going to be easier for you to look at it over there. But remember, we read that information. Okay, the second line over here, if I start here, it tells me, okay, graph F cuts the x-axis at A and B and the y-axis at C. The graphs intersect at A and C. So in other words, they're telling us, by saying that to us, they are telling us that C is the y-intercept of both graphs. Okay, X is the x-intercept of both graphs. Does that make sense to everybody? Okay, all right, good. Okay, so it's very important with every question in maths, guys. If it's a question that comes with information that we have to read first, as is so often the case, make sure you read that information very carefully just to start off with, because most of the time it contains important information that we need in order to be able to answer the questions. I cannot tell you how many times I myself have, I'll be at school and a student will come and ask me for assistance, and I'll take a shortcut and I won't read the information, and I look at the picture and I look at the answer and I can't do the question. And it's just because I didn't read the information. Okay, it's happened to me so many times. All right, so don't do the same thing. Okay, always read the information first. Ask yourself, what does it mean? Understand it, and then go and look at the questions. Okay, all right. I think we're ready to do 5.5 now. Now they want us to calculate the length of PQ. Now, again, this is a length question. They do not want us to use distance formula. Okay, it is a vertical line. They've also told us up here, and we know that it's a vertical line because they've told us that PQ is parallel to the y-axis. So can anybody tell me, can you guys tell me, how do we calculate the length of a vertical line that lies between two functions? What do I do? Does anybody know the method that I use here? Does anybody know the method that we use to calculate a vertical line between two functions? There we go. Okay. So, Lebogang, I'm not sure what you're saying, if you're saying the gradients are the same, M1 equals M2. I'm not sure what you mean by that. Fazama is saying top Y minus bottom Y. Good, Fazama. Thank you. Okay, that's perfect. All right, you're quite right. So when you want to calculate, let's just scooch over a little bit and I'll just draw something for you guys quickly. Okay. So if you have a set of axes, let's just draw a quick set of axes here. Oh, definitely not in bright yellow. Let's pick another color. There we go. All right, set of axes very quickly. Right. If you want to calculate the length of a horizontal line, okay, so let's say from there to there. Okay, so from that point to that point. And over here, let's say that that's -3, and let's say that this over here is 1. This is now the x coordinate. Okay, you would say, and if that's A and that's B, you would say that AB is the x at the right minus the x at the left. So you'd end up with that, and it would be 4 units long. When it is a vertical line, okay, this corresponds with the y at the top. That corresponds with the y at the bottom. So if I say that the y at the top here is 5 and the y at the bottom here is -8, if this line is PQ, then I would do exactly what Fazama says. The y at the top minus the y at the bottom. Okay, so that's how you work out the length of horizontal and vertical lines in functions like this. Okay, so it's the x to the right minus the x to the left for a horizontal line, or it's the y at the top minus the y at the bottom for a vertical line. Okay, the only thing is it just becomes a little bit more complicated because the y at the top is written as a function. Okay, so remember g of x is y. Okay, and q is a point on the parabola. The parabola is f of x, which is also y. Okay, so in order to get the length of PQ, looking at the diagram, we would say that PQ is the y at P minus the y at Q. The y at P is a point on the straight line. So the y at P, everyone, is x plus 5. That is the y at P. Remember, this is the equation of g of x. Okay, the y at Q is going to be the equation of the parabola. So now I'm going to have to minus -2x squared minus 9. Oopsie, bracketed too soon. Minus 9x plus 5. Does that make sense to everybody? Yes. So Msomi, when they ask you to calculate the maximum length of a line, I will show you how that is just, but it's the same idea. It's the same idea. Okay, you just have to maximize. So again, you can use x equals -b over 2a, or you could use calculus. But Msomi, I'll go back to that now and I'll show you what I mean about the maximum length of a line. Okay, is everybody happy with this, with what I've put on the screen? Okay, so the y at P is g of x. The y at Q is f of x. All right, and they've told us specifically at x equals 2. So in that vertical line, PQ lies on the line x equals 2. Neliswa, could you just help Bokang quickly in the chat for me, please? Thank you. So either what I can do is I can sub the x equals 2 in now, or I can remove my brackets and tidy it up a little bit and then sub it in. Okay, it really doesn't matter. Okay, so if I decide to remove my brackets, I'd have plus 2x squared plus 9x plus 5, and then at x equals 2, therefore PQ would be equal to, I'm just going to put it underneath because I don't want to go into this other purple writing here. So 2 plus 5 plus 2 times 2 squared plus 9 times 2 plus another 5. So that would give me how much for PQ? Okay, I'm getting 38 units. What have I done? Okay, sorry, I see some of you are disagreeing with me. Have I made a silly mistake? Okay, hold on a moment. Is what's supposed to be minus 5? Oh, sorry, here. Sorry. Oh, when I multiplied out my bracket. There we go. Beg your pardon. Negative times a negative is a positive. Yes, so that should be minus. Sorry, that should be minus. There we go. There we go. Are we getting 28 units here? There we go. Okay. All right. Thanks, guys. Thank goodness you are on the ball and watching everything so closely. See, it's so quick. It's so easy to make a silly mistake like that when you are distributing and not change a sign. All right. Cool. Let's move on. The questions now start to become a little bit more difficult. Question 5.6 and 5.7 are going to require some sort of deep conceptual understanding of functions if we want to be able to answer them and access these marks. If not, we have to be happy with 12 out of 18, but if we want more than that out of 18, we've got to be able to do the more difficult work as well. All right, so let's see what question 5.6 is asking us. They want us to calculate the value or values of h for which y equals x plus h will be a tangent to f. So calculating the value or values of h for which y equals x plus h will be a tangent to f. What is this linking to? Does anybody know which other section we study in grade 11 at the beginning of grade 11 and then we never do it again and you're expected to know it in grade 12? Not Euclidean. Well, I understand why you guys are saying that because of the word tangent. But it actually isn't, it isn't a link to something in paper 2. It's a link to something in paper 1. So some of us have made some suggestions. It's actually nature of roots. Oh, okay. Tan functions, is it trig? It's actually nature of roots. This is a nature of roots question. Do you remember nature of roots? The discriminant delta. Okay, that's what they're actually asking us a question about here, all right? So if a line, yeah, for real, Lebogang, if a line, so if we just go back and just think about our nature of roots, and nature of roots is so important to be able to answer questions like this. Just very briefly, if you have, let's draw ourselves another set of axes, okay? If you have a parabola, and we're talking about our set of axes over here, this parabola over here, that parabola over there, what do they have in common? What do these two parabolas have in common? Exactly, Fazama. They have no x-intercepts. Therefore, what could we say about their roots? Yeah, lovely. Well done. Exactly. So therefore, their roots are non-real. Okay, so in other words, delta, which is b squared minus 4ac, it's going to be negative. So b squared minus 4ac is smaller than 0. Do you remember this? Is it sort of coming back to you? Okay, so when there are no x-intercepts, roots are non-real. Now, we can have the same situation with a parabola and a straight line. So if I draw a line, and it doesn't matter whether it's horizontal or whether it is diagonal, but let's say I draw that line on the screen now. I can say that, and I'm going to get rid of the parabola down here. I can say similarly, okay, that the green parabola has no x-intercepts, okay, roots are non-real. But I can also say that that straight line that's on the screen right now, the purple one, and the parabola also have no real roots. But if I take this straight line and I move it, okay, so let's say I decide I'm going to move this line up, and it's now touching the parabola in one place, I can say that that straight line is a tangent to the parabola. Okay. Similarly, if I take a parabola and it now has its turning point on the x-axis, the x-axis is a tangent to the parabola. So when a line touches a parabola in one place only, we would say that that line or the x-axis is a tangent. So now here, all right, there is one x-intercept or one place where it touches. So the roots are no longer real. The roots are now real. Why it keeps changing my shapes? I think I need to take that off. Okay, so the roots are now real. Okay, the roots are equal. And if you recall, delta, or b squared minus 4ac, was equal to 0 in this case. Is that starting to ring a bell? Grade 11s and grade 12s? Is it a little bit more familiar now, what I'm talking about?
It looks like they get it. Sorry, Teacher Lee.
Okay.
I'm here now. Sorry.
Oh, hi, Yolanda. No, that's great. I'm so glad
Hi,
you were able to join us. No
Yeah.
problem.
Looks like
Okay.
everyone is getting it now. Yeah.
Okay. So, Jude, what I was trying to say here is that when a parabola either touches the x, or it's not a very good straight line, when a parabola touches a straight line, whether it's the x-intercept or another straight line on the Cartesian plane, if it touches in one place only, right? Then that straight line is a tangent to the function. It has real roots. Delta will be equal to 0 in this case. Okay, so this is what they want us to use to answer this particular question. So this is how we would do it. First of all, we would take, I'm just trying to think where's the best place. You know what I'm going to do, Matrix? I'm going to rub out 5.1 so that I can write over here. We've got this information anyway. So let me just do this. Okay, so our first step in answering this question is, again, you have to be able to know what part of maths are they actually asking us a question about. What does this relate to in our knowledge? So first thing. Second thing, we would take minus 2x squared minus 9x plus 5, and we would make it equal to x plus 5. Now we need to get it into standard form. So that means moving the x and the h over to the other side. So we've now got minus 2x squared minus 10x plus 5 minus h equals 0. It's now in standard form. That means the value of a is negative 2. The value of b is negative 10. C is everything else. So C in this case is 5 minus H. We need to sub that into delta. So B squared would be minus 10 squared minus 4 times A is negative 2 and C is 5 minus H. Okay, so this would give us 100. And then so now here, I know my grade 11s this year struggle with this. You are multiplying minus 4 with minus 2 with 5, and then minus 4 with minus 2 with minus h. Okay, so I need another 2 terms. Okay, so this would give me 8 would be 40. So this would be plus 40, and then that would be minus 8h. Like so. So that would give me 140 minus 8h. Okay. Tangent. The word tangent means equal roots. So in other words, delta is equal to 0. Okay. So for equal roots, delta equals 0. Okay, so now we would take our 140 minus 8h, make it equal to 0. I will Lebogang, that's fine, that's not a problem. I know it's something that a lot of students struggle with. And 8h is over here, the 140 is over there. So h would be equal to 140 divided by 8, which would leave us with 35 over 2. Okay. All right. So Lebogang, let me just explain that to you again. I know it's probably a little bit difficult to see with everything that's going on in the screen right now. Tell you what, let's rub this off as well, just to give us a bit more space here. Okay, so Lebogang and anybody else, right? You've got the minus 10 squared minus 4 times negative 2 times 5 minus h. So Lebogang, you are multiplying the minus 4 with the negative 2 and then by the 5. Okay, because C in this case is a binomial. So when you're expanding your brackets, you would have to multiply those three things together to get the first term. That's where the plus 40 comes from. And then you would have to multiply the -4 with the -2 by the -h. That's where the -8h comes from. Okay, so another way you could do this if you wanted to is you could say -4 times -2 is 8. Okay, so -8 times the 5 is where the
Sorry, shouldn't it be
be plus 8,
8?
plus 8,
Yes.
plus 8, plus 8. Sorry. So that's where the plus 40 comes from and where the -8h comes from. Okay, so if that's a little bit easier for you. Okay, you just multiply those two numbers together first. All right. There we go. Okay, let's have a look at the next thing. Okay, now that's only out of 3 marks. All right, so I think here there would have to be a mark for equating them, subbing into delta and getting delta equal to 0, and then a mark on your answer. Not very many, a lot of working and not very many marks for that particular question. Okay, let's have a look at 5.7. So grade 11s, this is not really going to mean anything to you at this stage. This really is for the grade 12s, but you're welcome to listen. Okay. I think you can still understand it even if you don't necessarily know the notation. Okay, so grade 11s, you don't know this. The matrics know this. Anybody in matric, what does this mean? In the context of this question, what are they asking me to look at specifically? When they say f of x times f prime x, what are they talking about? What does f prime x mean in this case? Yes, so the derivative of f of x. The derivative of f of x is the what? Give me another word for derivative. The gradient, exactly, the gradient. All right, so in other words, what we are doing to answer this question is that we are multiplying f of x, which is y, times gradient. Okay, that's what f of x times f prime x means. It means your y value times your gradient has to be negative. It has to be smaller than 0. So if they want us to come up with a negative answer, right, the only way that we can get a negative is either we multiply a positive with a negative or a negative with a positive. So now we have to consider where y is positive and where y is negative. Y is positive above the x-axis. Y is negative below the x-axis. Gradient, is positive when we're walking uphill, and it's negative when we're walking downhill. So in other words, we either want to be above the x-axis walking downhill or below the x-axis walking uphill. Does that make sense to everybody? So y, positive or negative, is above or below the x-axis. Okay, so either I'm above the x-axis or I'm below it. Gradient, when it's positive, I'm walking uphill. When it's negative, I'm walking downhill. So a place where I am walking uphill, where gradient is positive, but I'm below the x-axis, would be here on F. Their gradient is positive while y is negative. Can you see that matrix? Same story over here. I'm walking downhill, but I am above the x-axis. I'm walking downhill, above the x-axis. Okay. All right, so in the other regions that I have not highlighted, so between A and D, I'd be walking uphill above the x-axis, both would be positive. At B, both would be negative, gradient and y would be negative. Okay, so these are the places on the function that satisfy my inequality or what they're asking me for. Okay, so it needs to be an x value smaller than the x value at A. All right, so I know at A, x was equal to -5. So this is going to be where x is smaller than -5. Or where x is a number that's bigger than the x coordinate at the turning point. The turning point, its coordinates was -9/4. And between the other x-intercept at B, and that was where it was equal to 1/2. Okay, so either where x is smaller than -5 or where x is bigger than -9/4 but smaller than 1/2. Okay, so there would be an accuracy on that and 2 accuracy marks on that. You cannot write that in any other way unless, of course, you want to use brackets. So you can do this if you want to. So where x is an element from -infinity to -5 union. Oh, let's just get rid of this over here. And then here, -2. Okay. Lebogang, you got a hand up? You're welcome to ask, Lebogang.
Unmute. Yeah, you'll have to unmute, Lebogang. You are still muted, so we cannot hear you. You'll have to unmute on your side.
Lebogang says she can't unmute. I don't know why not.
I just fixed that, Lebogang. Just try now. There we go.
Thank you, ma'am.
There we go, Lebogang.
Ma'am, can I ask, for 5.7, is it the same as in like normal functions where they ask you if the x values where one function is above the x-axis and the other one below?
Yeah, absolutely. Absolutely. Yeah, it's one of those determined for which values of x. So, there's so many things that they could ask here. So they could say, for which values of x is f of x greater than g of x? Or for which values of x is f of x times g of x greater than 0? Or f of x divided by g of x smaller than 0? There's so many different things that they could ask there. But yes, it's one of those kinds of questions. Mesh, are you in grade? No problem. Are you in grade 11? I think you're in grade 11, Mesh. There we go. Okay, so they're not going to ask you this question in grade 11. This comes out of a matric paper. So in grade 11, they could say to you, for which values of x is f of x greater than g of x? Or f of x, they're not going to ask you a question about gradient. Okay, Mesh, because you haven't done f prime x. That's calculus. Okay, so I don't know if you heard me at the beginning of this question. I was just saying grade 11s don't stress. This is not something that you've done. Okay, so they won't ask you this in grade 11. Okay, next year definitely. Okay, but then you don't need to worry about that because you've got Watobe to help. Okay. All right, so let's go back and have a look at some of the other questions. What I also just wanted to share with you was a functions checklist. You can take a screenshot of this and then perhaps go through the checklist and say to yourself, are these things that I know how to do? So X and Y intercepts, do you know how to calculate them? Do you know what the rules are? And then hopefully we can say yes. Do you know how to write down the domain and the range, the coordinates at the turning points of a parabola, whatever the case is? All right, so what we've just done now, all right, in this question over here, the one that we've done together, we've done 5.1. That's a question about the x-intercepts. This is a question about the turning point. Yeah. Gugu, it's not an easy question. The length of OC, M and K is equation of a straight line. Calculating the length of PQ, so that would be up here, it would be how to find the length of a vertical line between functions. Then here, 5.6, calculating H, that was a link to nature of roots. All right, and then question 5.7, so that's why I've put up here, I've put nature of roots for you, so functions and nature of root applications, and then for which values of x. Okay, so Gugu, maybe you're not the only one, maybe there are other people. Is anybody else struggling to understand 5.7? It's only for the matrix. Yes, Jude. So the word increasing means a positive gradient. Okay, because y is getting bigger as x gets bigger. Okay, so if they use the words increasing, they're talking specifically about a positive gradient. Okay, if they use the word decreasing, they mean a negative gradient.
So we have
Okay.
3 learners that are, well, 2 more learners that are also don't understand 5.7. I'm not sure if it's only 3 or more, but so far I see 3.
All right. So when you say you don't understand, what is it that you don't understand? Can you be a little bit more specific?
Please feel free to unmute and then you go.
Go for it, Gugu. Go for it, Gugu.
Hi, ma'am.
Hi, Gugu.
So I'm struggling with, I can understand the question, but I struggle when it comes to the part where you highlight the graph.
Okay. Do you,
yes,
that's
yes.
fine. Do you understand why I've highlighted the bits that I have?
No, that's the
okay. All right. That's fine.
Okay. I know you're talking about the gradient, but I'm struggling to grasp that part.
That's fine. Okay. So I'll explain that to you again. All right. So when we talk about the value of y, okay, here is, let's just get a highlighter. There's your x-axis. Okay. So above the x-axis, this is where y is greater than 0. Y is positive. Below the x-axis, this is where y is negative. Okay. On this side of the parabola over here, all of this up to the turning point over there, your gradient is positive. So here I would say f prime x is greater than 0. On this side over here, let me just find a different color highlighter. Over here where the green is, after the turning point, your gradient is negative. So f prime x is smaller than 0. Okay, so where y is greater than 0, this means where y is positive. This is where y is negative. Gradient, this is where gradient is positive. The green, this is where gradient is negative. So you want your two things, your y and your gradient, to have opposite signs if you want a negative answer, so smaller than 0. Okay, so either you need to be below the x-axis where y is negative and where gradient is positive. So that is this part over here. Okay, below the y-axis where gradient is positive, but y is negative. That's this pink piece that I'm coloring in. Okay, Gugu? Y is negative, but gradient is positive. As you walk from left to right, you are walking uphill. Okay, but as soon as you get to A, you are now no longer where Y is negative. Now Y is positive. So the purple part, Y is positive and gradient is positive. That's not what we want, okay, because we want a negative answer. So a positive times a positive is not going to give us a negative. Then when we get to D, our turning point, our gradient changes and now we start walking downhill. Okay, now we are walking downhill where Y is positive until we get to B. So that's the other part that satisfies what we want, because now we've had a change in the sign of Y and we've had a change in our gradient. Okay, so our Y is positive, our gradient is negative. So that's why it's smaller than A or between D and B. I hope that helps.
Ma'am, sorry, I didn't raise my hand. So essentially, if I can simplify this, so essentially we were looking for where the gradient and the Y have opposite signs.
Correct.
On both halves of the function.
Correct.
Okay.
That's exactly what you are doing. Okay, so when they ask you a question about Y, so f of x, you're saying, am I above the x-axis or am I below the x-axis? You're looking at where Y is positive or where Y is negative. When they talk about gradient, again, it's the same thing. Is gradient positive or is gradient negative? So gradient is positive when you're walking uphill. Okay, so if you are over here, you're walking uphill. Over here, your gradient's not doing anything. And then when you get over here, you are walking downhill. So we always work as x is getting bigger. Okay, does that make more sense to you? Okay, all right, cool beans. Good. Okay, so maybe now you might be in a better position to at least attempt these sorts of questions instead of just always leaving them out. Okay, so maybe what we could do is go and have a look at the other parabola question, just because parabolas carry so many marks, and there's actually another interpretation here based on gradient on this particular question as well. Okay, which the grade 11s, again, you can listen to, but the one about gradient is not going to apply to you. All right, so let's see what they've told us here. They've given us the equation of h of x and of k of x. What do they say to us? H of x is x squared plus 2x minus 3. And k of x is minus x minus 3. T and Q are the x-intercepts of h, and T is the x-intercept of k. P is the y-intercept of h and k. So again, they're sharing an x-intercept and a y-intercept. They intersect at P and T. V is the turning point of h. So the first thing that they want us to do is write down the coordinates of P. That's only 1 mark. All right, so what would we do there? Can anybody tell me what are the coordinates at P? Based on the information that's given to us? Someone's put it in the chat. There we go. Okay, so be very careful, guys. Okay, when they ask you for coordinates, give them coordinates. Okay, very important that we do that. Yes, x would be equal to 0. You're quite right, Mbali and Zanele. And y would be equal to -3. Quite right, Gugu. Okay, so it'd be 0 and -3. Gugu, how did you know that? How did you know that the coordinates at P were 0 and -3? What were you looking at? Can you tell us?
When we're looking for the y-intercept, we let x be equal to 0.
Did you do that? Did you do a calculation?
Yes. Okay, by looking at it, I didn't, but by looking at it, I know, because when you multiply something with 0, it gives you 0. So we're only left with -3.
Exactly. Okay, so in other words, what you were doing is you were looking at that value over there, and you were looking at that value over there. Okay,
yes.
So there we go. Okay, because we were told that they intersect at P and T. So if they intersect at P and P is the y-intercept, then that value, the -3 over here and the -3 over there, that is your y-intercept value. Okay, so you don't want to go and throw away any marks here because you didn't write it as a pair of coordinates. Okay, let's look at the next question. The length of TQ. So when they say the length of TQ, what do they really want us to calculate? Exactly, they want the x-intercepts. Good, okay. They want the x-intercepts. It is a horizontal distance. Okay, so we want to let y be equal to 0 on h. Very important that we show that step. Make sure that when you factorize, you've still got your y equal to 0. Don't be lazy and don't write that. Okay, often there's going to be a mark on the line in which you have your factors. And if you've left off the equal 0, you're going to lose that accuracy mark. Okay, so don't go and do that just because you didn't write 0 equals. Okay, and then here we would have -1. So either x is equal to -3 or x is equal to 1. Okay, so that means that TQ would be equal to 1 minus -3, which is 1 plus 3, which would give us 4 units. Okay, good stuff. Well done. So this particular question, let's just go and see what its mark allocation was. 4 marks. Okay, so 1 mark for equal to 0. Factors must be equal to 0. Both answers, and then the 4 units over there. All right, now they ask us to calculate the coordinates at V. So, Rosaria, this goes back to you, what you were saying at the beginning of our lesson, okay, about finding the coordinates at the turning point. Remember, grade 11s, you have 2 options. Matrix, you have 3 options. None of us are going to do completing the square because it takes way too long. All right, you guys do that. Work out the coordinates of V, and then you're going to share your answer with Yolanda and I. Oh, wow, you guys did that super fast. Well done, everybody. Okay, so we can see that V is a point in the 3rd quadrant, so we're expecting a negative x and a negative y. Well done. Lovely, good. Nice. Okay, I think I'm going to use the x-intercepts here since I've just calculated them, and I know one of them is -3. I know the other one is 1. So that gives me -1. And then in order to calculate what the y is, I'm going to calculate h of 1. Okay, so remember to show your working. So that would be 1 squared plus 2 times 1 sorry, -1. Beg your pardon. What was it at the end? -3. Okay, and then that would give you -4. Okay, so again, they've asked us for coordinates. Let's give them coordinates, -1 and -4. Good, well done. Okay, beautiful, everybody. 3 marks. So either there'd be a mark for subbing into midpoint formula or subbing into x equals -b over 2a, or taking the derivative, making it equal to 0. Then we would get an answer on our x and subbing it in here and then getting an answer on our y. Okay, so 5.4. Now, who was asking me about this? Was it you, Msomi? I think it was you. Okay. So we can see here we've got a question about maximum length. Yes, Rosaria, before I carry on, what did you want to ask?
I mean, many of these type of
Rosaria, I'm just struggling to hear you a little bit. Just come closer to your microphone.
Can you hear me now, ma'am?
It's a little bit difficult for me to hear you. You sound very far away, but I'm going to listen carefully. Please speak.
Okay. So in many of these function graph questions, they would normally ask you maybe in the first 3 questions to find coordinates of things. But then what happens once you get one of them wrong, because you're still going to need those coordinates to carry on with the rest of the questions?
Yes. So that's why, Rosaria, what they do these days, and the Department of Education has been doing this for a long time, and your teachers at school should be doing this with you as well from grade 10, is that everything that you do should be continuous accuracy. So in other words, if you make a mistake, but your maths is correct, so let's say you make an arithmetic error, where instead of getting -1, you made a silly arithmetic mistake and you got -2. If you carry that -2 through correctly, you're still going to get the marks as long as your methods are correct. Okay, and they do that in paper 1 and paper 2. So any question where you are using information that you have calculated will always be continuous accuracy marks, so that you can still get the marks even if you've made an arithmetic error. Okay, so continuous accuracy is for number errors, okay, arithmetic errors. It's not for method errors. Okay, so your method still needs to be correct to get those marks. Okay. So that's nice. That helps. You've lost marks with that. Yeah. So that's what they're trying to do. Okay, so Msomi, it was you that was asking about this. So here we can see the maximum length of MR. So whether we were in grade 11 or in grade 12, we could be asked a question like 1.4. Now, the reason why they say the maximum length of MR, what they mean here, Msomi and everybody else, is that the length of MR can change. Okay, that's why they're saying that M is a variable point. So in other words, I can move M. So imagine, okay, if I could grab hold of point M and point R, and I could go up towards T. If I take M and R and I move up towards T, what's going to happen to the length of MR as I go in this direction towards T? What's going to happen to the length of MR? MR is going to shorten, exactly. It's going to get smaller and smaller and smaller. When I get to T, MR, the distance between M and R, is going to be 0, because M and R will be on top of one another at T. So as I move away from T, M gets longer, MR gets longer and longer and longer and longer until it gets to a point where it's the longest it can be. And then as I start to go towards P, what's going to happen to the length of MR again? Again, it's going to get shorter. So what they're asking us for here is that what is the length of MR when it's the longest it can possibly be between points T and P? Does that make sense? Okay, so what is the longest MR can ever be between point T and point M? That's what they're asking us in this case. Okay, the maximum length of MR. Okay, so first of all, we need to get an expression for MR using the y at M minus the y at R, like we did in that previous question. Okay, so we know that the length of MR is the y at M minus the y at R. What is the y at M? M is a point on the straight line. So if I go up and have a look, the straight line is k of x, which is minus x minus 3. So that is minus x minus 3. The y at R is a point on the parabola, So if I go up and have a look, that's h of x. That's x squared plus 2x minus 3. So this is x squared plus 2x minus 3. So again, if I remove my brackets, I'd get minus x minus 3 minus x squared minus 2x plus 3. If I've removed my brackets correctly. And then if I just simplify all of this, I'd end up with minus x squared minus 3x. Okay, so I've got the length of MR now in terms of x. The difference between question 5.4 and question 5.5 is that in question 5.5, it was easier because they told us that x was equal to 2 when we were calculating the length of PQ. Here, they do not tell us what the x is when MR is at a maximum length. So, if you are in grade 11, what you would do after this is you would go back to your formula x equals negative b over 2a. Because when you're calculating the x coordinate at the turning point, that is going to be the maximum length or maximum distance that your point can be from either the x-intercept or any other point below that. Okay, so you would use x equals negative b over 2a. This is if you were in grade 11 or in grade 12. So the 11s can do this, the 12s can do this, but the 12s have another option as well, which is to use calculus. So now we sub into x equals negative b over 2a using this information. All right, so negative b would be negative 3 over 2 times a. A is equal to negative 1 in this case. All right, so negative times a negative divided by a negative would be minus 3 over 2. So now I have worked out the value of x when MR is at its longest point. Okay, so MR will be its longest when x is a value of minus 3 over 2. Matrix, we can also use calculus if we want in this case. Okay, so for the grade 12s, if you have got MR equals minus x squared minus 3x, you can use calculus, derive. Okay, so the derivative of MR with respect to x, we would have minus 2x minus 3. Again, for a maximum or for a minimum, our gradient would be equal to 0. And then we would solve. So 2x equals negative 3 So x equals minus 3 over 2. Okay, so matrics, you can use calculus. Grade 11s, you would use x equals negative b over 2a. All right, or if you're in grade 12, you could do that as well. Now you can go back and go and sub in. All right, so in other words, to get the maximum length of MR, we're going to take minus the x squared minus 3x. We're going to sub in minus 3 over 2 squared minus 3 times minus 3 over 2 like that. Okay, and then you can work out what that is. Are you getting 9 over 4 or 2,25 units?
Let's see some answers in the chat. They're saying yes, from Somi. Yes, from Penyo. Okay, Bukang also said yes. Lebukang said yes. Yeah.
Yes, Gugule too. 9 over 4. There we go. Okay. Are there any questions about 5.4 before we carry on? You could if you wanted to, Jude. You could. You could. I would try and stay away from completing the square. It's not something that a lot of students get right, but you could. Yes, you can see 5.4 again, Oratile. Let me just go down. There you go. And I'll just... Yes, Ayanda. 5.5 is another grade 12 question. Okay, so the grade 11s could get something like x times h of x greater than or equal to 0. But in matric, the matrics are the only ones that will see h prime x. Okay, so I chose this question on purpose, actually, because of question 5.5, because I thought that that's something that probably not a lot of us would have seen before. Okay, this is not an easy question at all. Right, so let's just break it down into its parts. So for which values of x will x times h of x times h prime x be greater than or equal to 0? So this is a similar category of question to question 5.7. Okay, it's just a little bit more difficult. Okay, because now instead of them multiplying 2 things together, now they're multiplying 3 things together. So here, when they talk about x, they're talking about either to the left of the y-axis or to the right of y-axis. So where your x coordinates, is x positive or is x negative? When they talk about h of x, they're talking about y again. Right, so either above the x-axis or below the x-axis. And then h prime x, sorry, grade 11s, this again means gradient. So in other words, what we are doing here is we're taking x, we're timesing it by y, and then we're timesing it by gradient. And we want an answer in this case that is either equal to 0 or positive. So when we times these 3 values together, we want an answer that's 0 or positive now. Yes, this is for the matriculants. Okay, but grade 11s, you can still listen. It's just the H prime X that you wouldn't be expected to know. You still are expected to understand these sorts of questions. Okay, so if we go up and we have a look, X is negative to the left of the y-axis. It's positive to the right of the y-axis. Y is positive above the x-axis. Y is negative below the x-axis. When we talk about gradient, when we're walking downhill, gradient is negative. When we're walking uphill, gradient is positive. So gradient is negative before V. Everything before V has a negative gradient. Everything after V has a positive gradient. We're walking uphill. Okay, so we want a positive outcome. So either to get a positive outcome, either all of them have to be positive. So let's go and have a look at that. Is there a place on the graph where X is positive, where Y is positive, and that we mean the coordinates, and gradient is positive? Is there a place where that's happening? Can anybody see that on the graph? Where your X coordinates are positive, your Y coordinates are positive, and you are walking uphill. There we go. Yes, lovely. Okay, so from Q to positive infinity. Brilliant. Well done, guys. Very nice. So this part of H is where X coordinates are positive, Y coordinates are positive, and we're walking uphill. Awesome. So we found at least part of the answer. Okay, so if nothing else, at least we can get part marks for this and not 0. Okay, now let's go back and have a look at some other changes that we could possibly have here. We also know that a negative times a negative is a positive. So let's consider this. What happens if X was negative and Y was negative, but gradient would have to be positive? So now let's go and have a look in the third quadrant. In the third quadrant, is there anywhere that we are walking uphill in the third quadrant? X is negative, Y is negative in the third quadrant. Is there anywhere where we are walking uphill in the third quadrant? No, from T to V, we're not walking uphill. From T to V, we're still walking downhill. That's it, Gugu. You've seen it now. Between V and P. Yes, Lichlu. Yes, Lichlu. Very nice. Between V and P. X is negative, Y is negative, but we are walking uphill. Cool. Well done. Okay. Now let's go back and change something else. So let's keep X as negative. Let's change Y to positive. And now let's have a look at our gradient. So now if X is negative and Y is positive, we've got to be in the second quadrant. So here we were looking in quadrant number 1. Here we looked in quadrant number 3. Now we're going into quadrant number 2. Okay, so here, X is negative, Y is positive, but we're walking downhill. Is that happening in the second quadrant? Okay, so here. Okay, X is negative because we're in the second quadrant. Y is positive. We are walking downhill. Negative infinity to T. Yes, Lichlu, good. Okay. So in quadrant 2, X is negative, Y is positive, and our gradient is negative. Okay, as we come from negative infinity to T, we are walking downhill. Gradient is negative. All right. The last thing I suppose we should have a look at, if it's not going to work, is quadrant 4. Okay, so in quadrant 4, Y is negative, X is positive, Gradient would need to be negative, but there is no negative gradient. Okay, when we go from P to Q, we are only walking uphill. So we can't find what we want in quadrant 4. Right? It's not happening in quadrant 4 for us. Okay, now you all gone very quiet when I did the last highlighting, which was from negative infinity to T. Does that part make sense to you, or have I lost anyone?
Okay. So far, Gugu is okay.
Okay,
Anyone
Gugu's
else?
happy. Yes, it does make sense. Okay.
Okay.
All right.
Okay, looks like
Oh,
we're happy.
good. Oh, good. I'm so glad, Matrix. I'm so glad it's making sense. Is this the sort of question that ordinarily you would have left out? Would you have looked at something like that and said, I don't know what that means and moved on? Okay. All right. Would have definitely skipped it. And there we go. So, now you don't have to skip these questions if you understand what they mean. When you understand what stuff means, then it's not difficult anymore, but it's just understanding that. Okay. All right. So now we just need to write down our answer. Okay, so we've come from negative infinity to T. Oh, yes. So at T, what was our x? Our x-intercept here, I think was this was -3, wasn't it, at T? Is that right? And this was 1. Am I correct? And then at V, our turning point was -1 and -4. Okay, so let's write down our answer for 5.5. Okay, so where x is smaller than -3, that's this bit over here. V to P, it's between V and P. So we've got to say between -1. Oh, sorry, it says or equal to 0, right? So we can include these values. So between -1 and at Px was equal to 0. Or from Q onwards, or where x is greater than or equal to 1. Okay, so there you go. Those would be your 3 marks in this case. 1, 2, 3. All right. Okay, so we've got a little bit of time left. Let's go and have a look at the hyperbola question. Okay, if everybody's happy to do so. So, Gugu, the only time you use the word and is if you are solving for 2 different letters. So if I want to say at C, X is 3 and Y is 2, then I'm allowed to use the word and. I can't, it's here, it's or. So it's either where X is smaller than or equal to -3, or where X is between -1 and 0, or where X is greater than or equal to 1. Okay, so when we're solving for the same variable, we have to use the word or, because X cannot be 3 different values at the same time. Okay, that's what the word and means. Okay. Okay, so again, so Gugu, another way to think about it is like this. Okay, there will be other boys that are doing this. Okay, so things like girl and boy, either you are a girl or you are a boy. Okay, girl or boy, but you can be a girl and be in grade 11, or you can be a girl and be in grade 12. Okay, or you can be a boy in grade 11 or a boy and in grade 12. Okay, so the word and is when you are 2 things at the same time, or is one or the other. Okay. So union is for all, Lebogang. So you can use union here if you want to. So if you wanted to write your answer like this, it's the union of 3 regions. So it would be x is an element of negative infinity to negative 3. All right, union, square bracket, minus 1 to 0, union, 1 to positive infinity, round bracket. Okay, so you could use the union symbol here if you wanted to. Yes, that's correct. That's correct, Gugu. Union is the same as all. Okay. All right, guys, let's go back and have a look at the hyperbola. Hyperbola questions are all very sort of samey, guys. And when I say samey, I mean they often ask the same sorts of questions. So like the first one, write down the equations of the asymptotes. Guaranteed, they're probably going to ask you that if they give you a question on the hyperbola. Okay, so remember, a hyperbola has 2 asymptotes. It has a vertical asymptote and it has a horizontal asymptote. When they say the equations of the asymptotes, maths teachers are very particular about that. They want them to be written in the right way. So all horizontal lines have an equation y equals. All vertical lines have an equation x equals, and you must write them in that way. All right, so now this comes from our equation. Can anybody tell me what the equations of the asymptotes are? What is y equal to? Y is equal to 1, yes, y is equal. So careful, Oratile, y is equal to q. Okay, the x. Yes, there we go. There we go. There's the lovely word of the use. And look at what Lizuko has done here. X equals 1 and y equals 1. Lovely, Lizuko. Perfect. X equals 1 and y equals 1 as well. Okay, so remember over here where it says x minus 1, we know that that means that it has been shifted 1 unit to the right. Excellent. Well done, everybody. That's beautiful. Okay, so you know the equations of the asymptotes very well. There's our 2 marks over there. Good stuff. Now they want us to calculate the coordinates of A. Oh, sorry, I should have read the information first. The sketch below shows the graph of f of x, 4 over x minus 1 plus 1, and the line y equals x. A is the x-intercept, B is the y-intercept, and C is a point in the first quadrant, and it is a point of intersection of F and G. Okay, so calculating the coordinates of A, okay, again, this goes back to x-intercepts. Okay, so 4 is the A value, it is. What is the 4 at the top again? So that's right, Lebogang is helping you there, Rosaria, quite right. So it's x plus P plus Q. So that 4 over there, if it's positive, the graph is sketched in quadrants 1 and 3. When A is negative, then the graph is sketched in quadrants 2 and 4. Okay, cool. All right, thanks, Lebogang. That was a lovely explanation. Okay, so now for the x-intercept, Gugu says it's 5. Careful, Gugu. Remember, it's a point on the negative x-axis. Maybe you made a mistake there. Just careful. Just go back and check. Is it maybe negative 5? So at the x-intercept, y is equal to 0. So we would have 4 over x minus 1 plus 1. Okay. Now, this year with my grade 11s, I said to them, this is the only way I want you guys to do this. I taught them, and I'm sure Mr. S teaches you grade 11s the same way, and your teachers at school, take that Q value over to the other side and change its sign, and then cross multiply. It is the easiest way to solve for x. So now you've got the negative 1 into x minus 1 is equal to 4. So minus x plus 1 is equal to 4. So minus x is equal to, oh, I'm getting 3. So this would, or negative 3, this would be 4 minus 1, which would be 3. So x would be equal to negative 3. Okay, yes, I agree. Right, did they say coordinates? Calculate the coordinates. So again, they want coordinates, give them what they ask for, and then they cannot take any marks away from us. Okay, it's all right, Gugu, that happens. Okay, but that's where we went wrong. Okay, so do your teachers at school tell you to do the same thing? Does Mr. S tell you to do the same thing? Where you're taking that Q value over to the other side? Excuse me, changing its sign and then cross multiplying. Grade 11s? Yes, yes, he does. Okay, no, that is the best way to do it. Okay, nice. How many marks was that? 3 marks. So again, these are 3 marks we want, making it equal to 0. Simplifying and then getting our answer. 4.3, now we want the coordinates of C. So C up here, it told us it is a point of intersection. So what do we do when we want to calculate coordinates at a point of intersection? What's the general rule for points of intersection? Equate the graphs. Beautiful, Litlu, Gugu, Kotwano, make them equal to each other. And Mbali and Zanele were the first ones off there. Beautiful. Okay, so we're going to let F equal G in this case. Do we have an F and a G? Oh no, we've just got a Y of X. Okay, so we're going to let them be equal to one another. So we're going to take 4 over X minus 1 plus 1. Let's just make sure I've written that down correctly. Yes, I have, and it's equal to the line y equals x, so it's going to be equal to x. Okay, now, in my opinion, the easiest way for you to solve an equation like this is to multiply every term by the LCD. Okay, I'm going to write that here for you. Multiply every term by the LCD, and that gets rid of the denominator. So I'm going to take 4 over x minus 1, and I'm going to times it by x minus 1, plus 1, and I'm going to multiply it by x minus 1 equals x, and I'm going to multiply it by x minus 1. Does that make sense to everyone? I've multiplied every term in the equation by the LCD. Okay, so here that will cancel, and I'm just left with the 4. Plus 1 times x is x, and 1 times negative 1 is negative 1. X times x is x squared minus x. Now I want to get it into standard form. So I'm going to end up with x squared minus 2x minus 3. Okay, now I'm going to factorize. And 2 solutions for x. Either x is equal to 3 or x is equal to negative 1. Okay, so any questions about what I've done here before I finish off this question? Everybody happy with that? Yes, cool. We're all good. Nice. Okay, so now we've got to go back, everybody, and go and look at our diagram, because now we've got to make a decision. Is x 3 or is x negative 1? Okay, at C, x has to be exactly. We have to check which one works quite right. So at C, we're going to have to make a choice. So either you do not scratch out your solution that doesn't apply. Either you write NA, or you can put a line through the equal sign. These are your options, or you can even write at cx equals 3. Any one of those is fine. So we're choosing 3, and then the easiest thing for us is to always go and sub back into the straight line. In this case, it's the line y equals x. So if y is equal to x and x is 3, then it means that y is equal to 3 as well. So therefore, the coordinates at C will be 3 and 3. See, again, I use the word and. X is 3 and y is 3. Okay, but here with different values for x is 3 or x is minus 1. All right, so that was out of 4 marks. Our marks would be 4. Definitely equating. Always on factors, most of the time on factors. Don't leave off the equals 0. Probably both answers, and then that over there. Okay, it's out of 4. Determine the equation of the axis of symmetry of f that does not intersect f. Okay, so now this is an axis of symmetry question. So your axes of symmetry, just quickly in the time that we have remaining, okay, are straight lines in the form y equals mx plus c that go through, not go through, that cut your graph in half, okay? So if I draw this one on in purple, right, this will be the one that does not intersect, okay? The one that does intersect would have a positive gradient, and it would also go through this point over here in the center. By the way, the coordinates at this point over here would be 1 and 1. It's up to you. Sometimes teachers teach you rules. I think the easiest way to learn this is as follows. Either your line will be the line y equals x plus c, or it will be the line y equals negative x plus c. What I actually do at school, I don't know why I do this, but I actually don't even use c. I use the letter k, but it means exactly the same thing. You only have to ever work out the k. Your axes of symmetry will always have a gradient of 1 or negative 1. That never changes. So you don't ever have to calculate the gradient. You just have to calculate the y-intercept. Okay, so in this case, the equation of the axis of symmetry that does not intersect is going to be the one with the negative gradient because it's not allowed to cut the graph. The other line, as you can see here, is cutting the graph. So we have to choose the one with the negative gradient. So that's going to be this one over here. So for 4.4, we're going to use the line y equals negative x plus k. We then sub in the point of intersection, that point of intersection of your asymptotes. You could, Jude. You can. You can do it that way as well. Not a problem. Okay, so we know that they intersected at 1 and 1. We know that from question 4.1. And we can go and sub that in. So 1 equals negative 1 plus k. So k is going to be equal to, add 1 here, k is going to be equal to 2. So it is the line y equals negative x plus 2. There we go. All right. And that, I believe, is the easiest way to do that question. Any questions there? Are you sure? All good? All right, so let's do the last thing and then we can call it we can call it a day, and we've ended off and we haven't had to rush for anything. Let's just do the last one. So the last question is a transformation sort of question, 4.5. So again, if we understand what this means, then it's not difficult for us to answer the question. Write down the equation of G. If G of X equals minus F of X minus 2 in the form G of X equals. So first of all, what do they want us to do over here with that negative? That negative in front of the F, what is that an instruction to do? It's actually a reflection. What do they want us to do? Y has changed sign. So if Y changes sign, we have reflected it over the x-axis, x-axis, x-axis. Okay, Y is changing sign because G of X is now equal to negative F of whatever. Okay, so Y has changed sign. Okay, so it's a reflection about the x-axis or over the x-axis. So Y has changed sign. So I'm going to put in this 4, and this was X minus 1. And now this is an instruction to shift my graph to the right-hand side. Okay, they want us to subtract 2. So we're going to subtract 2 over here. In other words, we would be moving the graph 2 units to the right-hand side. Okay, so that's what I would end up doing. Okay, so when I add onto X, I move the graph to the left. When I subtract from X, I move the graph to the right. So this would end up being, let's just leave the negative outside for now. We've got 4 at the top. At the bottom, we've got X minus 3 plus 1. And now it's similar to that map. It's like a mapping rule. Exactly, Lebogang. Okay, so this would give us minus 4, X minus 3, minus 1. Okay, so I've expanded that negative to both terms in the brackets. Okay, and that would be how we would do question 4.5.